Welcome. Today we will be going through question 4 of the Maclaurin Olympiad 2017. The diagram shows a square PQRS with sides of length 2. The point T is the midpoint of RS and U lies on QR, so that angle SPT equals angle TPU. What is the length of UR? So for this problem, I will be sharing two solutions. One will involve trigonometric identities like sin alpha plus beta and cos alpha plus beta. So if you know those identities and you'd be interested in knowing how to solve it the trigonometric way, please feel free to skip ahead. The timestamp is in the description below. If not, just stay put and we'll go through the other solution. So hint number 1, construct some congruent triangles. How will you go about proving their congruence? Hint number 2, triangle TSP and TFP where F something 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 are congruent. What does this tell you about triangles TFU and TRU, and how will this all help you to find the length UR? Hint number 3, consider the angles around T. What sort of angles do you find, and can you think of any other angles that may be the same? So solution. Let F be the point in PU such that angle PFT equals 90 degrees. Then triangles TSP and TFP are congruent because angle TFP and TSP are both 90 degrees and angles SPT and TPF are equal as given in the question, and they both share the side TP. So TF equals ST equals 1. And then we find that triangles TRU and TUF are congruent. This is because TF is 1 and TR is 1. They both share the same hypotenuse and they are both right-angled triangles. Now let angle SPT be x. Then angle STP equals angle PTF, which is 90 minus x, and angle UTR equals 180 minus 2 multiplied by 90 minus x, all that divided by 2, which we find being x. And so angle TUR equals 90 minus x, and so we see that triangles STA and URT are similar in a 2-to-1 ratio, as SP equals 2 and TR equals 1. So UR is half of ST, which is half multiplied by 1, which is a half. Now we move on to the trigonometric way of solving the problem. So we're going to remind ourselves that sin alpha plus beta is sin alpha cos beta plus sin beta cos alpha. Sin alpha minus beta equals sin alpha cos beta minus sin beta cos alpha. I just realised that they're A's and B's, but never mind. Cos A plus B is cos A cos B minus sin A sin B. Cos A minus B is cos A cos B plus sin A sin B. If you've never seen them before, then don't worry, you can just skip this solution, and the first one was great as well. But nevertheless, we'll cover it anyway. So let angle SPT be x. Then angle UPQ is 90 minus 2x. Considering the triangle UQP, tan of 90 minus 2x is UQ divided by PQ, which is UQ divided by 2. And now considering triangle SPT, tan x is ST divided by SP, which is a half. Now tan 90 minus 2x is sin 90 minus 2x divided by cos 90 divided by 2x, and sin 90 minus 2x is cos 2x, and cos 90 minus 2x is sin 2x. So tan 90 minus 2x is cos 2x divided by sin 2x, which is cos squared x minus sin squared x divided by 2 multiplied by sin x cos x. If you are unsure of any of this can all be derived from sin alpha plus beta and cos alpha plus beta, but they're also very well known identities. If you're not sure, you can look them up. They're useful to know. So we know that tan x is a half from previously. So 2 sin x is cos x, which is just rearranging sin x divided by cos x equals a half. And so tan 90 minus 2x is cos squared x minus sin squared x divided by cos squared x. And so that can be rewritten as cos squared x over cos squared x minus sin squared x cos squared x, which is 1 minus tan squared x, which is 3/4, as we know that tan x is a half, so tan squared x is a quarter. And so we find UQ is 2 tan 90 minus 2x, which is 6 divided by 4. And so UR is 2 minus 1.5, so a half. If you didn't understand any of that, don't worry. It is a little bit complicated if you're seeing this for the first time. If you did, then great. It's probably easier than the first solution in that case. Anyways, hope you liked that video, and feel free to drop a like if you enjoyed this video and comment here. Goodbye.